Hey everybody, Mr. Bucko here with a couple problems from your Chapter 6 practice test. I got numbers 1 and number 2 on this video. Number 1's on the screen where it says quadrilateral ABCD is a kite with segment AD congruent to AB. So these two segments are congruent, AD and AB, and DC is congruent to BC. And that's what makes a kite, is that these two sides have to be congruent, and then these two consecutive sides have to be congruent as well. We have to draw the line of symmetry, or the lines of symmetry. There's only one in this instance, and that would be straight through A and C right there. There's your line of symmetry for this kite. Number 2, we have this figure here, which is a hexagon. It's a regular hexagon. That's not obvious. That would be a good question to ask or to clarify whether or not it's a regular hexagon or not. And it has n-fold symmetry, and n-fold symmetry refers to rotational symmetry. So how many times will we see this octagon as it appears here if we were to rotate it 360 degrees? And in this case, if we were to start here and kind of rotate this, and I'm not rotating that, I apologize for that, but if we were to rotate this thing, we would see this hexagon look exactly as it appears when this side gets to where this side currently is. So we'd see it once from there, and then when this side here gets up here, we would see it twice. When this side gets over here, we'd see it 3 times, and then 4 times, and then 5 times, and then finally all the way around would be the 6th time. So this has 6-fold rotational symmetry. N is 6, and the 6 represents that's how many times you will see the hexagon as it appears now when we rotate it 360 degrees. Part B asks, what is the smallest magnitude of rotation that will map this figure onto itself? So what that means is just what's the smallest degree of rotation you can turn that thing to make it look at exactly as it appears now. And that turn will come from when this side ends up right here. And all of these rotations are exactly the same measure because it's a regular hexagon. So we're going to take 360, the degrees taken to rotate it completely around, and divide it by 6 because we will see this hexagon 6 times and we will get 60. So the smallest magnitude of rotation would be 60 degrees.